Okay, now let's look at the last question on question 2. Okay, so they're saying a sample was selected of 500 workers who currently receive 2 weeks of paid vacation per year. Okay, and then they're saying these workers were asked if they were willing to accept a small pay cut to get an additional week of paid vacation a year. The following table shows the responses of these workers. Okay, so we have female workers and male workers. So we have man and woman, and then here we have their responses. Okay, so these are the ones that said yes, these no, and then these ones here did not respond. Okay, so this is the table that we've been given here. Okay, so the first thing here is to find the total in each of these columns and in each of these rows. Okay, so let's more like we draw this table and then we add the total there and the total that side. Okay, so I'm going to draw it in a simple way. Okay, I'm going to say, okay, so we have man here, then we have woman, and then I'm going to say we have total here. Okay, and then this side we have yes, we have no, okay, and then we have no response. So I'm going to write no response as NR, and then even here we should have what? Total, like that. Okay, so the ones that said yes, we were told that they were 73 if they were a man. For the woman, we had 104. Okay, so what is the total here? You just add on your calculator to the 73 plus 104. Okay, so the total here will be 177. And then they also said no. Okay, for the man, we had 140. And then for the woman, we have 117. So what is the total here down? We're going to say 140 plus 117. Okay, so we're going to get 257. Then those who did not respond, here we had 32. Here we had 34. So when you add this, what are we going to get? We're just going to get 6. Okay, and then let's add now all this row here to find the total there. Okay, so it will be 72 plus 140 plus 82. I'm going to get 245 here. Okay, what about if I add this row here? We're going to have 104 plus 117 plus 84 is equals to, I'm going to get 255. Okay, so now the funny thing or a very interesting thing happened. Okay, if you add all these totals and you also add all these totals in this row, you're going to get the same answer here. So let's prove that. So we're going to say 245 plus 255. I'm getting 500 as my grand total. Even if you add these ones here, you still get what? 500. Okay, so if you can separate this table into the rows and columns like that. So we have those demarcations there. Okay, so we've redrawn this table and we've added the column and the rows for the what? For the totals. Okay, so this is what we have here. Okay, and then we're going to be using this table to answer whatever questions we were given. So let's look at the first question there. So the first question they're saying, A, if one person is selected at random, okay, from these 500 workers, find the probabilities that that person said yes. Okay, so when you go here to find the probability of a person saying yes, okay, we are just going to divide the total that said yes divided by the total number of workers that we have. That would be the probability. Okay, so the probability of saying yes will just be equals to the total of people that said yes. Okay, so when you come to this column for yes, the total is what? 177. Then we're going to divide this by the total workers that we have, which is 500. So this is going to be equals to what? So we have 117. I mean 177. Okay, divided by 500. Okay, I'm getting my probability as 0.354. This is our first answer. Okay, then the second one, we want to find the probability of saying yes, given that it is a woman. So here we're finding a conditional probability. Okay, so the probability, this is number 2. We're finding the probability of saying yes, given that it is a woman. So how do you find this conditional probability? You simply say the probability of Y intersection W, and then you're dividing all this by the probability of what? Woman. Okay, so it means we have to find the probability of the intersection and the probability of the what? Woman. So the probability of yes intersection woman is going to be equals to, okay, so when you go on this table here, this is the column for yes, and then this is the column for what? Woman. So we are going to get the number that is intersecting these two. So if I go like that and then I go in this, we can see that they are intersecting in here, right? That's why you have your yes and woman. So the probability of saying yes and woman will just be 104 divided by what? 500. So we are going to say 104 divided by the 500 there. If you want, you can punch this on your calculator to make it decimal, or you can leave it like that for the meantime. And then let's find the probability of woman is equals to, okay? So when you go on this table here, the probability of woman, we want to get the total women in this survey, and then divided by the total number of people. So the total women will just go in this row for the women. So these are the total number of women. Okay, so the probability of getting a woman will just be 255 divided by 500. Okay, so this will be 255 divided by what? 500. Okay, so now we have this probability and that probability. We can substitute them into this formula to find the probability that it is yes, given that it is a woman. Okay, so this probability here, so probability of Y, given that it is a woman, is just equals to the probability of this guy, okay, which is 104 divided by 500. Then I'm going to say this guy divided by, okay, the probability of woman, which is 255 divided by what? 500. Okay, from here we can just do some algebraic manipulations. So this still remains 104 and then 500, then this becomes multiplication by 500 divided by 255. Okay, we see that this and this cancel. So we're going to remain with 104 divided by 255. Okay, so punch this value now into your calculator. So 104 divided by 255 is giving me a 0.40, 0.40, then 8. I'll end here. Okay, so this one here is the probability of someone saying yes, given that this is a what? Woman. Okay. So we've done this, and then let's solve for that last one here. So they're saying show that the events man and no response are not independent. Okay. And then show that the events yes and no, okay, are mutually exclusive. Okay, so we have to know the definition of dependency. Okay, so if man and no response are independent, then it means that in the intersection, okay, in the intersection of this man and no response, we are just going to find what? Okay, you should find, okay, just a minute. Okay, so I was saying to show that the events man and no response are not independent, we just have to show that the probability of man intersection no response, okay, is not equal to the probability of man multiplied by what? Probability of no response. Okay, so we know that if this definition, if what we have on the left here is equals to what we have there on the right, then it will be independent, right? Okay, so to show that they are not independent, we just have to show that probability of this side is not equal to the probability of this side. Okay, so let's find the probability of man and no intersection. Okay, so probability of man and no intersection, we'll go back to this table here. Okay, so from this table here, what is the probability of man and no intersection? Okay, so the probability of man and no intersection, you go to the row for the man and then column for no response. So we're going to get this value here and divide it by 500. Okay, so we're going to say probability of man intersection no response is going to be equals to, okay, 32 divided by 500. So 32 divided by 500. Okay, and then now what is the probability of man? Okay, probability of man, I mean, we are going to get the total mean that we have. So the total mean is what? 245 divided by 500. So 245 divided by 500. And then what is the probability of no response? Okay, we're going to get the total for those who did not respond. So this one here is the no response part. Okay, so the total for no response was 66. So to find the probability of no response, we are dividing this 66 divided by 500 there. Okay, so we are going to have, where is this gone now? I don't know if you guys can see my screen now. Okay, I'm sure I can see it now. So probability of no response will be equals to 66 divided by what? 500. Okay, so remember the claim that we wanted to show. Okay, we wanted to show that the probability of man intersection no response is not equal to the probability of man multiplied by the probability of what? No response. Okay, so if this is not equal, then we would have proved that this event and this event are not independent. Okay, so probability of man intersection no response, we are going to say is 32 over 500. So 32 divided by 500 is going to give me 0.064. So is this equal to the probability of this guy multiplied by the probability of this guy? Okay, so what is 245 divided by 500? I'm going to get 0.49. Then multiplied by probability of no response to be 66 divided by 500. I'm going to get 0.132. So now is what we have on your left equals to what we have on the right. Okay, so we're going to say this is not equal to, okay, because when I multiply this, I won't get this. So it will be 0.132 multiplied by 0.49. Okay, so I'm getting okay, so I'm getting 0.06 okay, 468. Okay, so this 0.064 is not equal to this number that we have on the right hand side there. Okay, they may look similar, but they're not equal. This one is simply 0.064, and then this one here is 0.06468. Okay, so they are not equal there. Okay, so if they are not equal there, you can conclude that hence not independent. Okay. Okay, so now let's check the last one. Okay, so the last one here, they're saying show that the events yes and no, okay, are mutually exclusive. Okay, show that the events A and B are mutually exclusive. Okay, so are these events mutually exclusive? The yes and the no. Okay, so two events are mutually exclusive if their intersection is empty. Okay, so if yes intersection no is 0, okay, then we say this event Y and this event N are mutually exclusive. So is the event yes and no mutually exclusive? So if you go back to this table here, okay, can we find anywhere that where the yes and the no are intersecting? Okay, you can't find anywhere. Okay, so since their intersection is an empty set, okay, or it's 0, then we can conclude that they are what? Mutually exclusive. So we're going to say since, okay, the probability of yes intersection no is equals to 0, okay, then yes and no are mutually exclusive. Okay, mutually exclusive. So that's how you should. Okay, so that was our last question here. Okay, so I thank you so much for watching the video.